Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning. Morning. My name is Jaime Puente. I am in charge of the Microsoft Research, External Research and Programs in Latin America. I want to welcome you to this Latin American session, and I am so excited, I'm so pleased at the same time to have this year at the Faculty Summit for the first time a time slot dedicated to the success stories that we have been having in Latin America. We are going to have three very well-known researchers from this region to tell you about how is the research agenda in computer science in this emerging region, as well as the regional organization and the existing cooperation programs. This region has been extremely active during this past year responding to our public request for proposals. And we have had only in this past year more than 15 award winners from Latin America, counting all the RFP winners and also researchers working in direct funded projects. Without any further, because time is limited to 1 hour, we're going to have three speakers talking to you for 15-minute period each one, and then we are going to have a general Q&A session at the end, so you can ask any one of these researchers a question. So I would like to introduce the three speakers that we will have this morning with us. First, we are going to have Dr. Ricardo Baeza Yates. He's a professor from University of Chile. Currently, he is on a sabbatical this year at University of Pompeu Fabra at Barcelona, Spain. Secondly, we will have Professor Carlos Enrique de Brito Cruz. He is the former president of one of the most recognized research universities in Brazil and Latin America, and currently he is the scientific director of the Foundation for the Support of Research in Sao Paulo, Brazil. And last but not least, we will have Dr. Miguel Nussbaum, professor and researcher from Catholic University of Chile. So let's welcome these researchers, and first let's have with us Ricardo. And thank you very much for attending the session.
Thanks, Jaime, for the invitation, and thanks for the people that is not from Latin America here. That's nice to see at least half and half, and so some people know about what's happening in the region. So Jaime asked me to tell, based on my experience, what's happening in the overall region, and then to talk a little bit about my research. But in 15 minutes, maybe I will not have time to talk about my research. So I will talk about some statistics, then what are the academic institutions in the region, and if I have time, I will talk about information retrieval and web mining, which is my own research, and many people may know one of my books. So, well, just to get the geography straight, that's Latin America. And I think last year was a very good economical year, and first time in this century really the per capita average on the region grew, and especially in the South Cone. So the main countries, you know, all of them, I mean, Brazil first, and then Mexico, Argentina, and then we have like Chile, Colombia, and Venezuela. So we did a study on the 15 years from 1984 to 1999 about publications on Latin America, and although it's not a straight line, it grows, it steadily grows. We have to update this study for the last 5 years, but basically the research is increasing in Latin America. That's very important. You can see that at the beginning only less than 100 papers per year. Now it's almost 4 times that number. Here are some approximate statistics, and we can argue with different Latin American countries about this, but we basically ask all the people that we know about all these numbers, and we got more or less this, and this is the situation currently in the region. So basically, number of researchers, Brazil has done a very good job on generating a lot of PhD people that's working at the universities, and being the largest country, that's possible. So then it's Mexico, Argentina, and Chile, more or less in the same situation, and then you have Venezuela and Colombia, and in the rest there is almost nothing. There's the number of universities that can be considered research universities in computer science. So clearly, again, it's the leadership is from Brazil, and then Mexico, Argentina, Chile, and Venezuela. We also checked CiteSeer and took the 9,000 most cited authors in CiteSeer, and we got these numbers. So there are 17 people working in Latin America, not people that was born in Latin America and are abroad, because those are higher numbers, and we're 17 people in that list. That's not too many, but at least it's not 0. And if you take people working abroad, people that we know, I mean, the number is much larger. At least there are 30 top Latin American researchers working abroad that are in the list. The most well-known is Hector Garcia Molina, Stanford. I mean, he's one of the top 10 in that list. So the main academic institution is what's called CLAY. This means Latin American Center for Studies in Informatics. It's not really a center that teaches, but basically it's a name to join all the institutions interested in doing teaching and research in computer science. It was born in 1979, and basically was to formalize an annual conference in the region that started before 1974 in Chile, and right now is the main institution that collects all the CS departments in the region, and also some outside the region. There's the website, you can go and check all the information there. There's an English and a Spanish version. We should have one in Portuguese, we haven't done it yet. So the main activity is this annual Latin American conference. Basically attracts about 800 people every year. It's the best way to go there and meet all the people. It's in all areas of research. This year, for example, they had 350 submitted papers, and about 30% are accepted. And it's a trilingual conference, so you can publish in English, Portuguese, or Spanish. So you have to learn at least one of those languages to be there, maybe not to talk to everybody. So at the same time, there's an Ibero-American CS Education Conference. When we say Ibero-America, we include Spain and Portugal. These are the roots of most Latin American countries. And we also have an award for the best Latin American master thesis, because only like 4 countries in the region have PhD programs. Doesn't make too much sense to have a PhD award thesis, maybe in the future. Also, we have cooperation with ACM and IFIB in specific topics. In particular, the last years we have been having a network, computer networks conference together with the main conference every year. And we have also electronic journal. It's also in the site of the CLAY. And this has been, we're already 7 years of publication. I will go fast here, but you can see that we go one country every year. So these are the last years of the conference. It's more than 30 years of conference. Even one was outside Latin America, was in Las Palmas, Gran Canaria, in Spain, to celebrate the 500 years of the discovery of America. So this year in October, and you're invited to come, the 31st conference will be in Cali, in Colombia, and organized by 2 local universities, and I think at least we will have again 800 people. So there, that's the website. Sorry, this shouldn't be there. So there are some national computer societies here. They are in order of age. So the first one was in Argentina in 1960. It was born first as Operation Research Society, and then also was computer science, and that was the oldest. Then the Brazilian Computer Society in '78. At the same time, it was the Mathematical and Computing Society in Cuba. I couldn't find the website, so I don't know if they have it, but I know it exists. Then the Chilean Society, Mexican Society in '95, Peru in 2001, and they're talking this year, I know, about the Colombian Computer Society. So maybe Venezuela is the next one, should be, so to have the main countries there. The first, at least Argentina, Brazil, Chile, Mexico are sister societies of ICM and IEEE Computer Society. We signed all the papers, but we never did too much. But those agreements exist. And CLE, well, CLE is 79, so it's between the first 5 organizations that were founded in the region more than 20 years ago. So the next year, next year, it's very important because we'll be with the first IFIP World Computer Congress done in Latin America. So that will be in Santiago de Chile, organized by the Chilean Computer Science Society in August. So we will have the Latin American conference together with the World Computer Congress. So there are several different tracks on different topics. So about cooperation, well, there are many ways that we can cooperate. There are bilateral agreements. I mean, most big countries have a bilateral agreement with National Science Foundation. There are some also regional programs like Mercosur. Mercosur, it's Brazil, Argentina, Uruguay, and Paraguay, and also has associated members Chile and Bolivia. And there are some research programs recently funded by Mercosur. Then we have several international programs, mainly with Europe. I mean, the European Union has been very active on having programs with Latin America, mainly because of Spain. Spain has a big tradition, historic tradition. So you have the ALPHA program to basically generate graduate resources in the region, so PhD interchange. You have also special program for scholarships called ALBAN. Fulbright also gives scholarships for Latin America to study in the US. And there's also an important project in connecting internet with Europe called ALICE. There's also a Ibero-American Science and Technology Cooperation that includes 21 countries that were in the past colonies of Spain and Portugal, so basically almost all the countries except IT in Latin America. And they have been funding projects in the last, this started with the 500th anniversary of the discovery of America, so in the last almost 20 years, started before that. So if you have any question later about that, I don't know how much time I have left, maybe now, nothing? 5 minutes, okay. So my own research. Basically, I am director of a special grant funded by the Chilean government called Center for Web Research. This is a part of something called the Millennium Initiative, funded by the World Bank. And it's the only one in computer science. Basically, we're about 10 researchers working on web problems, like web retrieval, information mining, image retrieval, web mining, distributed system, semantic web, and other people is working on those topics. I'm working basically on web mining and image retrieval. So just in 5 minutes, I will show you some results very fast. We have been working on crawling, on web characterization and dynamics, on the impact on search engines of web mining and vice versa. So what's the impact of search engines on web design, how to improve websites, and something we call query mining, which is quite new. So for example, just an example of our web phase search. So you put this as an input, and then you get that as an answer. And we are doing this with all the face images in Chile. So basically we have software that finds all faces with very, very good efficiency, and then you can search in about 2 or 3 million faces in online. So we're still improving the algorithm, but that's very exciting to do a face search on the web. So we have been doing also trolling. So this is the famous structure of the web published by Brother Troll in the year 2000. So basically you have a core that's largest, strongest connected component, and then search engines easily find this and this, but the rest is very difficult to find. So we have been characterizing, using all the domains in Chile, how large are these regions, what we can do to find all the web and so on. So for example, we have shown that the web not only grows, but also dies in a large percentage. About 20% of the Chilean websites die every year. And that was not known in the past, and basically there are no studies in the rest of the web. But it shows that the dynamic is much more stronger than you think. So this is how sites migrate in this web structure, and you see that most sites are born as an island. That means there are no links to them, and they don't have any links, and they, for the same reason, they die as an island. So basically, no traffic, no money. And we have studied all the interactions between different, how sites migrate in the structure, and this is a kind of visual mining. So you have 3 rows, 4 rows, every one is a year, and every vertical line is a website, where the color of the line depends on where it was in the structure. Green is our islands, red is the main kernel, blue is sites that only get links. So you see that there's a complete chaos in the left side. So you can have everything you imagine of a website moving there. If you focus only on the stable sites, so sites that are, for example, 4 years alive, you get this nice kind of Mondrian picture, but still you see at the left side a lot of chaos. So a lot of people are trying to analyze the web, and I think there's no point. It's like an amoeba after its 8 cells or something like that. I mean, growing very fast and no way to find. We're also working on this search engine and vice versa relation between web design. This is our causal model for design. And basically, we are studying what's called findability for search engines and for people. So how people and search engines can find sites, and then that means how you use web mining to get the back loop to this model. Sorry, I don't have time to talk more about the model, but basically there are some relations of design for crawlers, and there's also relations of design for people. So, and you can get all those things automatically. So basically we have been working on how to improve web design, and the main line of work, I will not talk about this normal, is how to do query mining, so how to extract information from queries, and then to improve web design, so also to improve search engines. So this is our main line of research. So questions? Well, later. So I'm done. Thank you.
Should I go?
Yeah. Now we have Professor Carlos Enrique de Brito Cruz, as I said before, former president of Unicampi, and currently the scientific director of FAPESPI, which is the research foundation of Sao Paulo.
Thanks very much, Jaime. It's a pleasure to have these 15 minutes to present to you some of the a quick profile of R&D in Brazil, and to mention one of the programs that we are working at in the state of São Paulo, funded by FAPESP, which is a foundation which operates more or less like your NSF here, except it's smaller in the number of millions of dollars. Well, I can skip the map. We have seen that. So that you have an idea, Brazil is the 11th country in terms of connected hosts to the internet. We have 9 million individual users, an inertial audience of 36 million, a large market for e-business. We have the 3rd largest internet banking operation in the world. And some major government applications. For example, we have electronic elections in Brazil, in which the elections for all offices, including the president, are made using an electronic system. You get the results of 130 million voters by 11 p.m. the same day of the election, and for several other offices in the country. We have a very interesting system for income tax collection, which receives 19 million income tax returns. 97% of the persons who present an income tax return in Brazil do that through the internet. And widespread system of e-government. Software in Brazil is a market comparable to that of India and China. We are talking in 2001, a number close to $8 billion. It's larger than that by now. And in terms of jobs, software industry in Brazil generates jobs for about 160,000 people. In terms of academic research in Brazil, talking about all fields together, we have experienced a strong increase both in the number of scientists covering several fields of science, and also in the number of scientific publications. That's shown in those 2 plots on the right-hand side of those pictures. Many of those publications are in very important scientific journals and were mentioned in the cover of those. For example, this one here in Nature was the first sequencing of a citrus pathogen that has a lot of bioinformatics into it, all of it done in Brazil. The formation of PhDs in Brazil is one of the strong points of academic R&D. Brazil now is forming almost 10,000 PhDs every year, which is a number comparable to India and China, and larger than South Korea or Canada and other countries around the world and in Latin America. This strong academic base is matched by a growing intensity of industry R&D in Brazil. For example, if we talk about Brazilian companies, the Brazilian oil company is the 11th largest R&D operation in the oil sector in the world. Embraer, which is an aircraft manufacturer, is the 17th in aerospace. Embrapa, which is a state-owned company for agribusiness research and development, is a very strong driver of Brazil's economy. Brazil is first producer in the world in soy in terms of productivity, first in meat exports, first in ethanol, and in many other cultures in agriculture. Foreign R&D investment in Brazil has also been increasing in later years. It amounts to almost $1 billion US 2 years ago, and recently there was this study by the Economist Intelligence Unit asking several international companies, in which of the following country does your company plan to spend most on R&D in the next 3 years? Brazil came out as number 6. After China, United States, India, UK, and Germany, which is not a bad position to be in this kind of ranking. As I mentioned to you, some of the interesting R&D results in Brazil and technology results, electronic elections, I've mentioned that, drilling oil at 5,000 feet under the sea. Brazil produces 80% of the oil it uses. Largest and most efficient ethanol producer in the world, Ethanol in Brazil is very widely used in automobiles. You have a large percentage of the cars on the street running 100% on ethanol. That is going to happen at some point in this country, but in Brazil it has been happening for many years now. Aircraft, soybean, and so on. Brazil has some strong programs to support partnerships between industry and university. At the state of São Paulo, there is this foundation called FAPESP, in which I'm the scientific director. We have a program for funding research projects arranged between university and enterprises. We fund from 30 to 70% of the cost of the R&D project, of the part which is done at universities. Federal government has several special funds for that, 2 of them in telecom and information technology. So it's something that is being very much fostered in Brazil through government action to connect academia and industry. I'll spend a few minutes talking about what we have in the state of São Paulo, which is one of the 26 states of Brazil. The state of São Paulo produces about 40% of Brazil's GNP and has about 20% of Brazil's population. In terms of scientific publications, if you would count the state of São Paulo as a separate country, it would be the one which has the largest scientific production in Latin America, followed by Brazil, then Mexico, Argentina, and Chile. We have 3 state universities which are pretty much research universities, which have a faculty of 10,000 and about 130,000 students. If those 3 universities would be put in a list together with the American universities that form the largest number of PhDs, University of São Paulo would be number 1. It forms 2,000 PhDs every year. University of Campinas would be number 3, forming 740 PhDs every year. And University UNESP, Universidade Estadual Paulista, would be, I guess, number 10 or 11 in this list. So there's a lot of a strong formation of qualifying persons in the state of São Paulo. There is this foundation which operates an annual budget of $200 million. Its budget is connected to the taxes that the state of São Paulo makes. Whatever money anybody pays in taxes to the state of São Paulo, 1% belongs to this foundation. It's an automatic budgeting. We support a lot of academic R&D, a lot of fellowships, cooperations with several countries. For example, with the United States, every day a scientist is packing its bags to go to São Paulo, funded by FAPESP. Every day in the year. We have about 360 American scientists come to São Paulo every year. We have programs that fund research in small business, which are patterned like the SPIR that exists in the United States. We have already 450 small business funded, many of them in information technology. And cooperative R&D, as I mentioned to you a minute ago. This is one of the programs that we are operating at FAPESP. We have been working with the idea of creating programs that might help to get the community of scientists to work together in some problems. So we organized this program related to information technology, called Information Technology and Advanced Internet. Its name is TIDIA, that would be those words in Portuguese. And this program works mostly in the hardware side of internet and connections, and also, mostly I would say, on the software side. Its aim is to foster academic and industrial R&D on topics related to very high-speed optical network, to foster cooperation between academia and industry, and to study the economic and social impacts of very high-speed networks. Very high speed means terabit per second. We built an optical test bed which connects 5 cities in the state of São Paulo. We bought the fiber. We have full access to the fiber, so we can cut the connection, rebuild the connection, include the instruments, do anything we want with it. It doesn't belong to the telephone company. It belongs to us. So the program TIDIA is divided into 3 main sub-projects. One is called Kia Terra, which is the terabit per second stable network. It connects 27 laboratories. 14 are working in electrical engineering, 4 of them in computer science, 4 in chemical engineering, 3 in physics, 1 in mechanical engineering, 1 in biomedical engineering. All in all, this project involves more than 100 PhDs and several hundred PhD students. A second project on TIDIA is e-learning, which connects 15 laboratories to develop applications and knowledge related to e-learning. More or less, a little more than 60 PhDs work in this part of the project. And then there's also a content incubator, which was built more or less following the pattern of SourceForge, so that people can build applications and software to foster cooperative software development, open source software. We have now 54 research groups as users of this incubator. I'll talk just a little bit about Kia Terra. Will take only more 5 minutes. Kia, which is the name we have chosen for that. Terra is from the terabit. Kia is the word which the native Brazilians, the Tupi Indians, use it to call a net. So it's a net, a fast net. It works on research in internet enabling technologies, communications, networking, remote control of lab instruments. We have a nice web lab system working with all those 27 laboratories using fiber to the lab. We have that dark fiber I mentioned to you. The project works on an applications layer, a transport layer, and a physical layer. We have 3 companies that work with us in this project, which are Corning, Optical Fiber Systems, and Padtech, which is a Brazilian company that makes equipment for high-speed internet. And finally, to sum up, just to sum up what I have shown here, Brazil is the 7th software market in the world. Sales of $7.7 billion in 2001, climbing up to almost $20 billion in 2004. 3rd country in internet banking, strong academic base for R&D, government funding for university industry R&D projects. Actually, there's almost more funding than we can use for this kind of program. And there is a very capable, very strong availability of human resources. Thank you.
Now we have Professor Miguel from Catholic University in Chile.
Thanks, Jaime, for the invitation. I won't talk about research in Chile nor in Latin America. Jaime invited me to talk about my project, which has been supported also by Microsoft. What's the problem and what's the solution? When you develop software, you have to have something in mind. And what we had in mind, especially what I had in mind, like 10 years ago, was this classroom. It was the same classroom I was in, the same classroom you were in, and the same classroom my kids and your grandkids will be in. The point is, can we do something different? Can we have active children and not passive children? Can we have a teacher that's not a god that's illuminating knowledge, but a mediator in the classroom, a real active teacher, and not just like a video showing to the children? What we did is the following. Our aim is to use technology in a very transparent fashion. We want that the children work first collaboratively. Here you see 3 children working in a group, working with the notes, with the books, and the technology is like calculators. They're transparent. But these calculators are pocket PCs with Wi-Fi. They're interconnected, And these are the active elements that make that these children really work collaboratively. What you see here is a change of roles. The children are working actively inside the classroom in groups of 3, while the teacher is now the mediator that solves the problems for those children that really need it. What we do, we give the teacher a tool that monitors what's going on inside the classroom, and so he goes to those children that really need the support he can give. Engagement is a key issue. You see here how the children are working collaboratively. See how this girl is showing the other 2 kids what she's doing and how they compare what she has done with what they are doing. So this is really constructivism. Everybody has a piece of the activity, and together they have to construct it. You can see it very easily in this way. Here, look at the children. They are discussing, this is 7-year-old children, they are discussing how to build up a series of words. Each of them has 1 letter, and they have to construct words with the letters. They are discussing, they are interacting. And look how immersed they are in the activity. They are really learning, but they are happy learning. While on the other side, the teacher is moving in the classroom looking for those children that really need the help. How we used it. We have a database in a web-based system where the teacher downloads the contents to the Pocket PC. The teacher goes to the classroom. Each child receives a Pocket PC, and with Wi-Fi, he sends the contents to the children. The children are randomly grouped in 3. 3 is the best size group for doing collaborative work. This has been shown by different researchers. And while they're working, they do different activities, like the following one. Here, they have 1 question and they have alternatives, different alternatives. If they don't agree in a given alternative, for example, this guy selected this one, the other guy selected this one, and they're waiting to the last guy. So they have to wait until the whole members of the group finish the work. Once they finished, and if they don't did what they have to do, the system says you have to agree in a given answer. So the system supervises that they're really working in a way that it's aimed to. The second one, it's also a very similar thing that has been done on tablet PCs, is the following one: to have a distributed PowerPoint. Think we want to work with poor children. We're thinking also in Latin America, where the technology has to be as cheap as possible. Each child has 1 machine, so we want to save the overhead projector. So what you have is the teacher's machine and the children's machine, and everything what's shown on the teacher machine is also shown in the student's machine. So he also has a pen where he can write on the screen, and this appears also on the student's machine. After a couple of slides, the teacher wants to know if the students really understood what's going on. Now I'm just talking, and I don't know if you're working on your PCs or you're really listening. If I now would send a question and see what's going on, I could have a feedback of the classroom. And that's what we do here. We send a question to the children after a couple of slides, and the teacher receives immediate feedback, and also the children receives immediate feedback of what's going on the lecture. So in this case, half of the class had it wrong, and the other half has it right. So the teacher now knows if he can proceed to the next couple of slides, or it's better to make a rehearsal of what was going on the classroom. We have worked with 8 schools last year, involving 2,500 students, and we got very interesting results. The first one, which is very amazing, is this one over here. This is a very, very, very poor school in the south of Chile with Chilean natives, the Mapuches. It's a small school where in the last year of the school they have 40 students or 45 students. Usually 25% of the students reach the minimum level to apply to the universities. Or the dimension is that in Chile there's a national test which almost all students give, and to go inside the university you have to reach this minimum level. 25% of these kids reach that level. And last year they used, during the whole year, once a week, this technology for teaching math, and they raised that number from 25 to 47%. With the rest of the country, we obtained different results, ranging from 15 to 32% of increase. The size effect was from medium effect to a large effect. I don't have it here. The conclusion basically was the following one. Our conclusion for doing an effective technology transfer has to have 3 points. The first, there has to be a very clear aim for the school. If the aim is not transcendent for the school, the technology won't be appropriated. We work with the government, and the government wanted to use this technology for teaching physics, to show that if we can improve physics, they said you can improve everything. And what we discovered is that the teachers and the schools are really not interested in teaching physics. So the technology was not an aim. We changed that for example, teaching for the university test, and that's changed completely. The second, the principal has to believe on the project. If the principal doesn't believe on the project won't transcend within the school. The teachers won't have really time to employ this technology inside the classroom. The time is not only inside the classroom, they have to, at the beginning, prepare themselves, understand the technology, and they have to have the time. And third, there has to be a leader in the school. If there's no leader in the school that shows how the knowledge is being used, if he's not enthusiastic about it, there won't be somebody that really will move this technology inside the school. If these 3 points won't happen in the school, we showed that this technology, I think not only our technology, any technology will fail inside the classroom. What I didn't show is that we also use the technology for teaching teachers, updating their knowledge. We taught 400, I think there was a little more, 422 teachers around the whole country in like 10 different cities, teaching science and math mainly, and we obtained in only 20 hours of teaching using this technology an increment of 18% of their knowledge of their own subject matter. We obtained last year an award of the Organization of American States for using technology for really transforming the classroom, because today's classroom is the same classroom of 200 years ago, and when we obtained that prize, they mentioned it, that technology is really a tool for changing these dynamics. And for finishing, I want to share with you what I found walking in Los Angeles on the street. Thanks. Thank you, Miguel. What I would like to do now is to invite back to the podium Ricardo and Professor Brito, please, for a general Q&A session. So please, if you have, I have this one. Any question, either to Miguel, Ricardo, or Professor Brito, please, welcome. Make it. Come here to the middle, it looks like.
This is a question to the panel and the session as a whole. I'm Daniel Pitt. I'm from Santa Clara University in Santa Clara, California. We're a Jesuit Catholic university. And we in California are faced with this issue of globalization every day. But it's only talked about with regard to China and India. We have historical ties with the Universidad de Centroamericano in San Salvador. We have just started some engineering collaboration on senior design projects and study abroad and distance learning. I'm looking for opportunities to use Latin America for international learning experiences for our students to familiarize them with globalization instead of with China and India, because we have these natural affinities. And most of our projects now are in mechanical and civil engineering. I'd like to expand them to computer science and engineering, and I'd like your ideas on how we in the U.S. can collaborate with Latin American universities instead of China or India to give our students these experiences?
Can I start? We are doing reverse technology, and I am working, my group is working in transferring this technology not only in Latin America, we're doing it now in Argentina, we're moving to Brazil with Fundación Bradesco, and we're moving to Mexico. But now we're also going to do it with Stanford Research Institute, and we're going to do it in the UK with the University of Bristol and the British government. So this is sending technology from Latin America to the first world. So I am open to that people from the US come and visit us and stay with us.
It surely seems like a very interesting possibility for us in Brazil. We have had programs with other universities, but as Ricardo mentioned, for some reason Europe has been much more aggressive in developing scientific and academic cooperations with countries in Latin America than the United States has been, even though the United States would have all kinds of natural facilities for doing that, since most of our faculty studied here or worked here for some time. Nowadays, in most universities in the state of São Paulo, we send hundreds of students for a stay of from 6 months to 1 year in Germany, Portugal, France, Italy, through programs of joint diploma and joint studies. And it would be very interesting to do that with institutions in the United States. I know that the National Science Foundation has a program which funds research cooperation between research groups in the United States and in Brazil. That would be one of the instruments to be used for that.
I just want to add that maybe it depends on the point of view, because I think the European researchers are in many ways more interested than US researchers in cooperating with Latin America. I mean, they see the region in a different way. I don't know why. Research collaboration is like a peer-to-peer collaboration, but sometimes I think the US looks at Latin America like nothing good is there, especially in technology and computer science, and it's not true. Maybe it's not as much as the US, but Brazil has done impressive growth in the last 10 years, and the same with locally in other countries. So I think just a matter of wanting to do that, because with Europe we do a lot of collaboration, and with the US it's very hard. I don't know why.
Yeah, I would like to add something very quickly. The External Research and Programs Office from Microsoft Research is also will be very glad to help with these collaboration efforts. You have here at the Faculty Summit 26 professors from Latin America attending the event, representing like 12 universities, so you will have a lot of opportunities to interact, and please, I ask you to do so, and if in case you need any help from me, please just let me know. We'll be glad to do so.
My name is Marshall from Argentina, from the University of Buenos Aires. Which is the cost of the hardware for your project? The cost of the hardware.
The cost of the hardware.
This is a very important point.
This is good news. When we started the first machines 3 years ago, when our first implementations, the cost of the machine in the US was $650. Today, the cheapest machine is a Dell that costs $229. So it went down 3 times in 3 years. So if you extrapolate, in 3 years it would be $70, less than $100. But today it's $220.
How many
machine.
How many machines you have for this project? How many?
How many you need? One for each child. In Chile, you have classrooms of 45 children, so you need around 50 machines, including one of the teachers. So the implementation like this costs $11,000 if you don't include the taxes. In Chile, the machines cost, with tax and everything, cost $300.
Okay. So I want to ask you another question. What are you doing in GRID in Brazil, in GRID projects?
There are projects working in grid computing, mostly in the physics community.
I imagine.
One of them is researchers from the University of São Paulo in nuclear physics. They work together with people here in, I think it's Oak Ridge. I'm not sure which lab it is here. And there are also researchers from the University of Campinas and Universidade Estadual. But I wouldn't know the details about the projects, but we can find everything in the internet. It's there.
So with the super collider in CERN, you're not doing anything? Not yet.
I'm not sure this program includes CERN and the super collider. I'm not sure about that.
Okay, thank you very much.
I'd just like to, I'm from Brazil, okay, and I'd just like to add something to the answers that were given about your question on cooperation with students, exchanging students. What happens is that we work on a credit system, and when we send our students to France or Germany or United Kingdom, they can take a credit for the courses they take there. So it's kind of a co-op thing. They work for 6 months and they do coursework as well. So when they come back, they do not feel as if they've lost 1 year of study. And the same happens, we receive students from France, from Germany, that take courses with us, and when they go back home, they can also use their coursework towards their degrees. But this is in a university per university basis. So in this sense, that's what Carlos Brito was talking about. For us, it's easier because in Europe we find more interest in receiving Brazilian students, and therefore it's like an exchange program. So maybe you can talk to us afterwards about that. Okay. Oh, when they come to Brazil, they have to when they take courses, they have to do it in Portuguese. It's all in Portuguese, so that's certainly a deterrent. But if they do not come for coursework, but just for like junior research projects to work with some professor, then they would speak in English. Okay. But certainly, if they speak Spanish, it helps.
I would like to add something about Claudia's comment. And for example, in my project, I receive students coming from undergraduates from Germany, and now I have a Finnish student. And when we ask people coming for a postdoc, we have people from France, or Belgium, but never we receive applications from the US. I don't know, and we distribute it in all the lists, in typically data world for databases and information retrieval and so on. But even we have PhD students from France, so it's a different approach. I mean, some people look for a topic, a professor, and then doesn't matter where, and maybe they like Latin America.
Hi, Max Costa from the University of Campinas. I'd like to make a comment also on these initiatives. We have recently signed an agreement between UNM, University of New Mexico, and UNICAMP for not joint degrees, but double degrees. So the students go through their programs and masters and PhDs, and they get both degrees from both universities. Of course, the requirements are not the sum of the two requirements. It's less than the sum, but it's more than the individual programs. And one of the things that are very synergistic is the thesis. They only have to do one thesis. It's translated in both languages, and they don't have to worry about the translations because this is going to be paid by the program. And this is something that UNM is actually using as a model for other similar programs with other universities. And we would like to have this also happening with UNICAMP, to have this being extended to other universities in the US and elsewhere. PhDs and master degrees.
I think we have time for one final question, so if anyone has an additional question, feel free to ask.
Even though the agreement was signed between the two universities, it was really focused on electrical and computer engineering.
I give an example. Last November, we graduated a PhD student, and he got the degree from a French university and from our university. He was a French student, and he wrote it in English, so no translation needed. And their PhD course is in English, so we have a common language there.
What opportunities are there for faculty to participate in the research? Obviously, NSF, I believe, has a program to send faculty abroad. And I've seen the announcements. Unfortunately, I'm not a citizen. I'm in this limbo where I'm a resident but not a citizen, so I can't take those opportunities. But I was wondering if there were other opportunities in the countries.
I think Fulbright has a new scholar program, including Europe, so maybe there. But I don't know if you, for example, if NSF you apply for, if you say you're doing research in Latin America, I don't know how good punctuation we'll get, because they will think that, well, the person is going for tourism and not to do research or learning. And I mean, those things exist. I mean, there's a view of not equal level. It depends on the topic, and matters.
Well, in Brazil, if you have an invitation by faculty in any university in Brazil which has a strong research program, it's very possible to obtain support from Brazilian funding agencies. As I mentioned before, at FAPESP, every day we fund an American or a scientist from the United States to go to São Paulo and work for 1 week, 3 weeks, 6 months, together with colleagues in some university. Federal agencies in Brazil also have programs like that, and this is something that we value a lot, because we believe it's good to have those exchanges and interactions and so on. So there are many opportunities for that in Brazil.
Okay, I think unfortunately we have run out of time. I want to thank very much to Professor Rito, Ricardo, and Miguel. Please, I'd like to